This is Big 5 acceleration example number 2. This one has acceleration due to gravity in it. First, we read the problem. During an exciting physics demonstration on freefall, Mr. Fair drops a student off of the football stadium. If the student took 1.4 seconds to hit the ground, from what height was he dropped? So we begin, after we've read it, we now would be drawing a picture. What is going on? Here is the student falling. Remember, we don't need to spend so much time on drawing the student, although I will put some safety goggles on just to imply that we are taking safety into account. This is the initial velocity up here, the dropping point. This is the final velocity just before hitting the ground. This here is the displacement. And notice he is accelerating downward. So that is my diagram. Next, I will list out my variables, the initial velocity, final velocity, acceleration, displacement, and time. Initial velocity, even though it's not actually given, the initial velocity is 0 because you think about it, the student wasn't tossed up in the air, it wasn't thrown down, it was just simply dropped. The final velocity, I'm not interested in right now. That's the second part. Acceleration, once again, not actually given, but is the acceleration due to gravity, which is represented with the g. That's negative 9.8 meters per second squared. The displacement, that's what I'm looking for. And then the time is 1.4 seconds. So if I'm looking for my displacement, that means I've got to use, and I don't care about my final velocity, that means I'm going to be using this equation here, d equals VIT plus 1/2 AT squared. This is nice because it's already solved for displacement, and the initial velocity is 0. So that means this whole thing right here is equal to 0. That makes it simple. D equals 1/2 AT squared. Now I can simply plug in, and I've got D equals 1/2 negative 9.8 meters per second squared. That is multiplied by 1.4 seconds, quantity squared. That means D is equal to, let's see, tapping into our calculator, negative 9.604 meters. Taking significant digits into account, I'd have 9.6 meters. And notice I dropped off the negative sign because I solved for the displacement. I was actually looking for the height. And height is a scalar, so height does not have direction in it. So that means I dropped the negative sign. The second part, I'm looking for the final velocity. So that means I go back to my original setup. I don't have to change anything other than saying final velocity is now what I'm looking for, and I don't care about the displacement. Even though I technically did solve for it, what if I made a mistake? So I'm not going to use that variable if I can help it. So I don't care about displacement. That means I'd be using VVAT, which is VF equals VI plus AT. Once again, very nice because it's already arranged for me. And in fact, that's 0. So final velocity equals acceleration times time. Acceleration is negative 9.8 meters per second squared. Then I need to multiply this by 1.4 seconds. And let's see, final velocity would equal negative 13.72 meters per second. And it is a final velocity, so I would keep the negative sign in there, but I do need to round it off because of significant digits. I'd say 2, so that'd be negative 14 meters per second with only 2 sig figs. Physics, yeah.